Today I would like to share some knowledge about how to port iOS applications to Windows 8. If you have experience in developing iOS applications, this course is for you. In this course, I will try to create mapping relationships between iOS and Windows Store apps, allowing you to learn Windows Store app development faster. After this course, I expect that you know the similarities and differences between these two platforms, and the best replacement when you port a certain feature to Windows Store apps. Due to time limitations, I do not want to touch on the details such as language syntax and API usage. You can get the reference from MSDN. As opposed to traditional desktop applications, Windows Store app provides the new UI and new programming stack. You can still develop classical applications in Windows 8, but it's out of the scope of this course. In this course, I'll first compare the programming architectures between iOS and Windows Store apps. Next, I'll introduce the required development tools. Then I'll give you an outline of the design principles for Windows Store apps. After that, I will compare the difference between iOS and Windows Store app controls. I will also talk about application lifecycles in these two platforms. Lastly, I will introduce how to load and install application settings or arbitrary data into a device. As you know, iOS is a totally different platform from Windows 8. So as an iOS app developer, you probably don't understand the programming architecture of Windows Store apps at first sight. I will compare the programming stack layers between them so you can get a clearer picture. The implementation of iOS technologies can be viewed as a set of layers. At the lower layers of the system are the fundamental services and technologies on which all applications rely. Higher level layers contain more sophisticated services and technologies. Cocoa Touch layer contains a key framework for building iOS applications. This layer defines the basic application infrastructure and support for key technologies such as multitasking, touch-based input, push notifications, and many high-level system services. Media layer contains the graphics, audio, and video technologies to create the best multimedia experience available on mobile devices. Core service layers contain the fundamental system services that all applications can use. At the bottom is the core OS layer of iOS, which contains the low-level features that most other technologies are built upon. Let's take a look at the programming stack for Windows Store apps. Similarly, the bottom layer is the core of Windows kernel, which also provides the drive level support. The layer in green is the Windows Runtime Library. WinRT is a native library, but it exposes APIs directly to different languages by projection. WinRT APIs is the successor of old Win32 APIs in Windows 8. WinRT APIs consists of multiple namespaces. For example, UI, storage, network, media, etc. Windows metadata describes the types of Windows runtime objects. Here, language of projection is the way to expose native APIs to three types of languages: native languages like C and C++, managed language like C# and VB.NET, as well as web languages such as HTML5 and JavaScript. Besides WinRT APIs, Windows 8 style apps also support a subset of Win32 APIs. If an application is written by managed code such as C# and VB.NET, a subset of .NET APIs is also supported. You can check which APIs are supported by Windows Store apps from Microsoft MSDN. Please take a look at this graph. Just as mentioned in the previous slide, Microsoft implements all of these features which iOS has in WinRT. Yet, we provide these features in different namespaces. You still can find similar hierarchy in WinRT. On the top, it is a namespace for user interface. On the bottom is the fundamentals to support all higher layers. In iOS, you have to use Object-C to create apps. However, you have three different languages available to create Windows Store apps. They are C# or VB.NET, C++, CX, HTML5, or JavaScript. Now let's talk about the development tools in Windows 8. Here I list the tools required for developing iOS and Windows Store apps for comparison. Software Development Kit is the first thing to be installed. To develop Windows Store apps, Windows 8 SDK is required. Integrated Development Environment is also necessary to edit and compile source codes of apps. For Windows Store apps, Visual Studio 2012 is the only choice. Visual Studio 2012 is a powerful development tool which has included the necessary components of Windows 8 SDK. So, it's not necessary to install Windows 8 SDK separately if Visual Studio 2012 is installed. Interface Builder, which is now integrated to Xcode, is the only tool for UI design. However, Microsoft not only provides integrated UI design tools in Visual Studio 2012, but we provide a more powerful design tool, Expression Blend. This tool is currently included in Visual Studio 2012 installation package. Visual Studio 2012 also provides a powerful debugger tool, VSJIT Debugger. It helps the developer to trace the executions, set breakpoints, and view various data in the memory. WinDBG is another debugger tool which can be used to debug applications or even the entire OS. iOS provides a simulator that helps to test the application without the real iOS device. Since Windows Store Apps runs on Windows 8, emulator is not required. Nevertheless, for the convenience of testing applications on tablets, we still provide a simulator for tablets. It can help the developer to test the layout with a common touch and rotation events. Here is a flowchart of the setup development environment for Windows Store Apps. First, you can install Windows 8 SDK to get a full version of header files, libraries, and tools. This setup can be skipped because Visual Studio 2012 has included the necessary components of Windows 8 SDK. Next, you should install Visual Studio 2012. After the installation, you are ready to create your first Windows Store app. To create a fantastic Windows Store app, we should know how to design the application UI. Windows Store app UI design has a set of guiding principles. It helps you to make the best choices when designing your apps. These principles are the foundations of building great Windows Store apps. Please always ensure your design and development choices adhere to these principles. Before we start to introduce the design principles, let's see some of the differences between iOS and Windows Store Apps UI. This screenshot shows iOS home screen. It is comprised of application icons. These application icons are fixed images. You can also see the badge on the top corner of the App Store and Mail icon. On the bottom, there is a bar. Users can dock their frequently used app icons there. This figure shows the start screen in Windows 8. It's comprised of bold, vibrant, and crisp colors. We call this color block or image tile. You can treat the tile as an application icon. The tile can be resized to square or made wider. Windows can also update an image and notification automatically. If you have a real Windows 8 PC, you will be able to see that the images and the text on the tile are changed dynamically. The image and the text can be pushed from the cloud or local. The tile is updated through a special thread in the system, so your applications don't need to be launched when updating the tile. As you can see, Windows 8 start screen is more vivid than iOS home screen because of these live tiles. Now let's take a look at an application in iOS. This is a UI of Wikipedia client in iOS. Wikipedia client owns a very simple UI. It just includes the search bar and article on the main page. On the top of the screen, there is a status bar which belongs to the system rather than the application to show the system status. The Wikipedia client in Windows 8 uses the entire screen to display content. There is no search bar nor a status bar. All the articles are well organized in a grid view by category. You can get more content by using the horizontal UI bar. Since there is no search bar, how do we search keywords in Wikipedia? Actually, the search function is integrated into the system. If I move to the right corner, charms will be invoked. Charms are system-wide commands, which include search, share, start, devices, and settings. We can search keywords by using the search charm. For instance, if I type elephant, then the Wikipedia client will show the search result immediately. Now we can summarize the similarities and differences between iOS and Windows. Basically, we share the same objectives. The applications and UI should be brief and clean, vivid and immersive, fast and fluent to respond to user interaction. But we designed UI from different perspectives. iOS UI tends to use decoration to glorify applications. In contrast, Windows Store Apps UI tend to show the content first. iOS UI uses fantastic real 2D and 3D objects, while Windows Store Apps UI uses bold, vibrant, and crisp colors and images as well as abstract symbols to represent real objects. iOS UI allows you to apply multiple art styles to your application only if it can make your application look more beautiful. For Windows Store Apps, we hope to bring a consistent UI experience to end users. You can have your own special design for your application. However, it is recommended that it is compatible with the system UI style. So far, we have discussed the principle of Windows Store Apps UI style. Now let's take a look at controls we can use in the Windows Store Apps. Some of iOS controls can be mapped to similar Windows Store style controls. For example, you can use text block controls as a replacement for label controls in iOS. You can refer to this table for more available controls in Windows 8 for replacement. Currently, we don't have a built-in date and time ticker or ticker control in Visual Studio 2012. However, there are some projects for these two controls available in Codeplex websites. Here I will list all the available built-in controls in Windows Store style apps. These controls are simpler, clean, and elegant. You can also write your own controls or customize the built-in control style, but we should keep UI style consistent. As you know, in iOS, we use storyboard or nib file to describe the app's UI and animation. In fact, storyboard is an XML-based file. In Windows 8, we use XAML to describe the UI. XAML is a XML-based markup language as well, so both UI language files have similar concepts and syntax. You can treat the XAML structure as an element or attribute tree. Each control is a XML element and each property of the control is an XAML attribute. XAML can also define resources and styles which can be referenced in the same scope. But XAML language is more flexible. For example, the control content property in XAML can accept any type of objects. So you can show a text, image, or even a video on button control without writing a new type of button. That's what we call containment friendly. Another key difference between XML and XAML is that XAML can have templates. Templates can be used to replace the view completely. We can define a template with a totally different view, and then use the template to replace the control default view. Next, let's talk about two important different competencies between iOS and Windows 8. Outlet is often used in iOS apps. An outlet is a property that is annotated with the symbol IB_outlet whose value can get set graphically in the nib file or storyboard. You declare an outlet in the interface of a class, and then you make a connection between the outlet and another object in the nib file or storyboard. When the file is loaded, the connection is established. Here, I have created an outlet for a label control, and then I can change the property of the label by referencing the outlet. However, it would be incredibly easy to achieve the same thing in the Windows 8 app. Using XAML, you can specify the name for any control of apps, and then you can access the control via name in the code behind the file. Please take a look at the screenshots below. On the left, you can specify the name of the text box control as label 1, and then on the right, you can change the property of the text block by referencing the control name. Target action is a design pattern in which the object holds information necessary to send a message to another object when an event occurs. The stored information consists of two items of data: an action selector, which identifies the method to be invoked, and a target, which is the object to receive a message. The message sent when the event occurs is called an action message. Although the target can be any object, even the framework object, it is typically a custom control that handles the action message in the application's specified way. Again, trigger a handler for a certain event is incredibly easy. We can do the same thing by adding an event handler for a click event in Visual Studio. On the left, there's an event click, defined as a button class. You can specify the event handler for it directly in XAML file. On the right, Visual Studio's 2012 will automatically generate code for the event handler. Now, let's move on to the application lifecycle. Technically speaking, both the iOS and Windows Store apps allow only one application to execute in the foreground at a time. The foreground application owns the screen and receives the touch event. They both support multitasking and fast application switches. However, the execution model of iOS apps are still slightly different from Windows 8 apps. Let's briefly review the iOS execution model. With iOS 4, it introduces multitasking, with the ability to do fast application switching. In this state, the application is expected to save data. If the user switches back to this application after using another application, the background application transits to the foreground and is made active again, at which time the user can resume where they left off. Additionally, iOS 4 also supports other forms of multitasking, such as task completion or background execution for applications using audio, location, or VoIP. This is very similar to Windows 8 scenarios-based multitasking. Next, let's see the execution model of Windows Store apps. It looks simpler than the iOS does. When you click the tile of the application is activated from the not running state to running state. The application exclusively owns the entire screen. We have variant ways to activate other Windows Store apps through contractions or extensions. For example, you can activate a camera app from your current application to take a photo. Then the current application comes into the suspended state, and the new camera application comes into a running status. After the photo is taken, the camera application is suspended and terminated, and the suspended application resumes to the running state. Like iOS, Windows Store apps suspend any invisible processes and both OSs using scenario-based multitasking strategies. A suspended Windows Store app still stays in RAM but can't get CPU time unless it gets resumed. It means that by default any task will be stopped if the application is switched out. It is fine for most scenarios, but it can raise several issues if the application needs to download something or backend network connection. To solve such kind of issues, developers can use Background Transfer API to download or upload files in the background. Background tasks can help to run code without launching the application. Here is a list of major scenarios which need leverage multitasking for Windows Store apps. The first scenario is downloading and upload files in the background. You can use Background Transfer API to implement it. The second one is run lightweight code in the background. You can call Background Transfer API. Background tasks cannot run code that directly update UI. Instead, they show information to the user by notification. Some applications, such as Mail, Instant Message, and VoIP, need this feature to keep user communication alive. The third one is to play audio in the background. Media Element Control has integrated this capacity. You just need to enable the capacity by setting the auto category to background capable media. The following table provides mapping between iOS, callbacks, or delegates and Windows Store app events related to the application lifecycle. For example, application did enter background is called when the app is in the background in iOS should be replaced with application. Suspending event handler to save app state, application will enter foreground should be replaced with application resuming event handler. Please note, some delegates are not directly mapped to Windows 8 events. For example, application will resign active happens when the foreground app is interrupted. On the other hand, application did become active will be called if the user ignores the interruption. We don't have a replacement in Windows 8 for these two delegates because you can handle these events in suspending and resuming events as well. Finally, we will talk about data storage. Both iOS and Windows 8 provide a way for application to store data locally. For example, application preference, files, as well as database. Just the same as iOS, the internal storage area is private to each application. But for Windows Store apps, only the specific folder can be accessed, such as Documents, Pictures, and Music folders. If you want to access an arbitrary file in the system, you should use File Picker to select the file. Another thing I should note is Microsoft doesn't provide database support for Windows Store apps yet. However, SQLite provides an extension to support Windows Store apps. With this extension, we can write Windows Store apps with local database support. Let's have a look at how to store application settings. In iOS, it is recommended to centralize the app preference in the system settings. There are some third-party libraries you can use to implement in application settings. In Windows Store apps, the application settings are stored on a pre-application basis. You can use application data current local setting property to save the preference locally, or use roaming settings property so that other devices installed in this application can also use these settings. Generally, you should load settings when the application is active and store settings when the application exits. In Windows 8, you should fetch the settings in OnLaunch and Application Resuming Event Handler. Write data in Application Suspending Event Handler. Besides application settings, Windows 8 also allocates isolated storage for every application to save the private data. There are 4 different folders. Local folder is used to save persistent data that exists only on the current device. The data in the temporary folder works like a cache. It can be removed by the system at any time. The data in the roaming folder exists on all devices on which the user has installed the application. The application can also access the Install Location folder, which contains the application package. This folder is read-only. If you want to store data, you should use the previous 3 folders. Windows Store app doesn't provide a general external storage due to security reasons. You can access some known libraries such as Documents, Videos, Music, and Picture folders directly. Nevertheless, you should declare capabilities in manifest files before accessing. You can also access SD storage through movable device properties. For security reasons, applications won't allow access to arbitrary files in devices implicitly. If you want to access a specific file, you should use the File Picker to select this file explicitly. Then the application gives the permission to access this file. This is all for porting iOS apps to Windows 8. Thank you for your time!